right, so today we are going to talk about inverse functions. We have two learning goals. We want to be able to find the equation for a function's inverse, and then we want to be able to determine, if we're given two different functions, to decide if they are indeed inverses of each other. Now, being able to do that, we have to be able to do that two different ways. We want to be able to look at their equations and say whether they're inverses, so that would be algebraically. And then we also want to be able to look at their graphs and decide if they are inverses. So what an inverse relation does, and this is what we did at the beginning of your activity, is it switches the input and the output values. So what was an x in the original is the y in the inverse, and vice versa. Also, in our discovery activity, we discovered the relationships between the graphs of the linear functions that are inverses. So the two functions you worked with in the activity were both lines, but the relationships we discovered are going to be true for all types of relations. So when you are looking at the graphs, again, the relationships between the graphs, when you are looking at the graphs of inverse functions will always be reflections of one another, and not just any reflection, always a reflection in the line y equals x. Now remember, y equals x is the line that cuts diagonally through. This is the line y equals x. So when we're saying we reflect it over this line, that means we flip it over that line. So graphs, if they are inverses, are going to be reflections over that line. So if you folded your coordinate plane on that line, the diagonal, they should line up on top of each other. Now, it's not always practical to graph all of our functions and then attempt to see if they would be reflections of each other. If we have the graphs, it's really easy, but if we don't already have them, it just takes a lot of time. So we also want to be able to find the equation of an inverse relation without graphing. So the way that we are going to do that, and this is probably the most important new thing, because some of the stuff we did in the discovery activity, this we didn't. If you want to find the equation of an inverse relation, what you are going to do is switch the places of x and y and then solve for y. So if it gives you an equation and asks you to find the inverse, switch x and y and then get y alone, and that's it. Now, we know when we're given two functions graphs how to decide if they're inverses. We look and see if they're reflections. If you have both relations or equations and you want to know if they're inverses, instead of solving and doing this, you can simply decide using your compositions, which is what we discovered in the activity. Because if they are inverses, f of g of x should simplify to x, and g of f of x should also simplify to x. So if you do both of those compositions and you end up with x for both of them, they are inverses. We call this right here, this notation, we read that f inverse, not f to the negative 1x. So we just read that f inverse. So just because f of x is a function, meaning each x is assigned to exactly one y and it passes the vertical line test, doesn't mean that f inverse is necessarily a function. So we have to decide if it is also a function or not. And the way that we do that is the horizontal line test. Now, when you're deciding if a given function or a given relation is a function, we did the vertical line test, and if a vertical line touched more than once, it wasn't a function. But here we're taking the original and trying to decide if the inverse would be a function. So that is why we switch it to the horizontal line test, because With inverses, the x's and y's are switched. So instead of a line that is an x equals line, we switch it and make it a line that is y equals. So if any horizontal line touches the graph more than once, then F inverse is not a function. So if the horizontal line touches the original more than once, then F inverse is not a function. All right, so to quickly summarize, we've talked about three things. If you're given the graphs and you want to know if they're inverses, you do the reflection. Are they reflections in the line y equals x? If they are, they're inverses. If they're not inverses. If you want to find the equation of an inverse, switch x and y and solve for y. If you're given two different equations and you want to know if they're inverses, do both compositions and see if you get x for both of them. So let's take a look at some examples applying those rules. So example 1, find an equation for the inverse relation. So again, if we want to find an equation, it's right up here. Switch x and y and solve for y. So switch x and y is my first step. And then I'm going to get y by itself. So subtract 6. These are not like terms, so that just gives me x minus 6 equals negative 3y. And then divide by negative 3. So y equals 1x divided by negative 3 is negative 1/3 x. Negative 6 divided by negative 3 is positive 2. So negative 1/3 x plus 2 would be the inverse relation for y equals negative 3x plus 6. So let's try that again. On B, first thing we need to do is switch the x and the y. So x equals 4/3 y minus 7/3. So now I need to get y alone. So first I'm going to add 7/3 to both sides. Again, these are not like terms, so I've just got x plus 7/3 equals 4/3 y. Now I need to get rid of that 4/3. Remember, to get rid of a fraction, you multiply by the reciprocal. So I'm going to multiply this entire thing, both sides, by the reciprocal, which is 3/4. So on the left side, 3/4 times x is 3/4 x. 3/4 times 7/3, the 3's cancel, so you just end up with 7/4. And on the right side, 3/4 times 4/3 cancels, so y is alone. So y equals 3/4 x plus 7/4 is your inverse relation equation for this original. All right, so switch x and y, solve for y. Now, example 2, verify that f and g are inverse functions. Use your English skills here. The word verify means show that it is true, which means they're telling us that these are indeed inverses. We just have to prove it. So, if we're asked if two relations are inverses, we decide using compositions. We know that these are inverses, which means we want to show that f of g of x equals x and g of f of x equals x. Now, I always get what I call fakers on this. You know what the answer is, so you write something random down in between and you write the right answer and you think it's going to be right. I know what the answer is. I'm checking your work. So don't try to pretend. You actually need to come up with and have work to support the correct answer. So I'm going to do f of g of x first. So that means f is my outside function. So I take this function, take the x out of it, and leave a blank parenthesis. So -2 blank parenthesis plus 4. G of x is the inside, so I put this function inside that blank parenthesis that I left. And now simplify. Again, show me the work. Distribute. So that's going to give me the -2's cancel. That just gives me 1x. -2 times 2 is -4. And then don't forget this plus 4 on the outside. Well, x minus 4 plus 4, these 4's are going to cancel. So I've just got x. Again, you should know what the answer is. It should be x. But you have to have all the steps of work to back it up. Now I'm going to do g of f of x. So now g is the outside function. So I use this, -1/2 blank parenthesis plus 2, and fill this guy into the inside. Distribute. -1/2 times -2 is +1. -1/2 times +4 is -2. Then I've got my plus 2 on the outside. Again, these cancel, and I've got x. I am done with my verification. I verified that both compositions were equal to x. So yes, that means that these are indeed inverses. So let's try it again with different functions, nonlinear ones in this case. So f of g of x, I take my f, this, 3, blank parenthesis, cubed, plus 1. G of x here, x minus 1 to the 1/3 over 3. So this whole thing, x minus 1 over 3, raised to the 1/3 power. Now this looks super hard. It's not, guys. Remember, power of a power, 1/3 times 3, it's just 1, which means this x minus 1 over 3 is just to the first power. So it's just itself, and then plus 1. The next step, because you have to show all the steps, 3 and the bottom 3, these cancel, because this is 3 over 1 and this 3's in the denominator. Those cancel, so I end up with x minus 1 plus 1. Then the 1's cancel, and that equals x. Again, show each step. I always get people who try to just cross off everything and think that that shows that they know it. It doesn't. You need to show each step. So now, g of f of x, so this is my outside function, so I'm going to leave this parenthesis blank. So blank parenthesis minus 1 over 3 raised to the 1/3. And inside that parenthesis, I put my f of x, so 3x cubed plus 1. So to simplify, inside the parentheses first, I can, since this is subtraction, you don't really need the parenthesis that we set up. So this +1 and this -1 cancel in my first step. So then I've got 3x cubed over 3 raised to the 1/3 power. In my next step, these 3's cancel. So I've got x cubed raised to the 1/3, which is x to the first, which is x. So I got x, I verified. And there we go. Example 3, find the inverse power function or nonlinear function. So example 3 is the exact same thing as example 1, except that they're not lines, and that they used this function notation. Don't let them trick you. Remember that f of x is the same thing as y. This says y equals 8x to the 5th power. So switch x and y and solve for y. So first I switch x and y, and then I solve for y. This is just what we did in section 7.1. Get the power term alone, so divide by 8. So that gives me y to the 5th equals x over 8. And now to undo a fifth power, I take the fifth root. Fifth root, fifth root, y equals fifth root of x over 8. Now, you do not need to rationalize that. I just want to know, can you switch x and y, and can you get the y by itself? You do not need to rationalize denominators. Again, there are already questions that will test whether you know how to do that or not. So we can leave it just like that. B, same thing. Remember, f of x is y. It's the same thing. So my first step is to switch x and y. So x equals 3/5 y cubed minus 9. Now get the y alone. So add the 9 first. That gives me x plus 9 equals 3/5 y cubed. Then I need to get rid of the 3/5. So I multiply both sides by the reciprocal of 5/3. So 5/3 times x is 5/3 x. 5/3 times 9. If you don't know, you can use your calculator to help you, but that gives you 15. 5/3 times 3/5 cancels, so I just have y cubed here. So now one more step to get y alone. I have to undo that cube by taking the cube root on both sides. So I've got y equals the cube root of 5/3 x plus 15. Again, no need to rationalize. All I want you to do is get that y alone. All right, last ones. Graph the function f, so f of x. Use the graph to determine if f inverse is a function. So this is where we're using the horizontal line test. So use your graphing calculator, type in to your y equals 2x squared minus 4, and hit graph. You should get something that looks like this. And you don't have to make an exact graph here. I just want to see that you know what it looks like. So do draw the picture, but you don't have to be exact. So then, horizontal line test. If I draw a horizontal line, does it touch more than once? Yes, it touches here and here. So that means f inverse is not a function. The reason is because the original fails the horizontal line test. Last one, same thing. Type this function into your y equals x cubed plus 3. Draw its sketch. Should look something like this. And then do the horizontal line test. Horizontal line, that only touches once. Once, once, once. All the horizontal lines I'm drawing touch only once. So in this case, f inverse is a function because it passes the horizontal line test. All right, that is it for today. See you next time.